Good morning, friends. Myself Devraye-Patil, here Department of Chemistry, late Ramesh Pudkar ACS College Sonpet, District Parbhani. Today uh, we will study the next part of atomic structure and wave mechanics. The topic is the Compton effect. The figure shows the Compton effect, where is X-ray striking on electrons get energy, and the X-ray get scattered. In this topic, we will see the Compton effect, which provide the direct confirmation of particle nature of radiations, and why photoelectric effect cannot exhibited by free electrons. So, in previous topic, in photoelectric effect, which provide the energy quantized in a quanta, to establish the particle nature of radiation, it is necessary that photon must carry some momentum. So, in 1922, Arthur Compton studied the scattering of X-rays of known frequency from graphite and looked at the recoil electrons and scattered X-rays. So, what is Compton effect? So, let's we define this effect as the effect that is observed when X-rays are scattered on a material with an increase in wavelength. That means when the X-ray falls on the material, then that X-ray will scattered, which having increasing the wavelength. So during this study, Compton found that wavelength is not depending on the intensity of incident radiation or X-ray. It is totally depending on the angle of scattering of X-ray and the wavelength of the incident X-ray. In that figure, the electrons revolving around the nucleus in an atom, the incoming X-ray which falls on the revolving electrons get energy and re-radiate, oscillate, and the remaining X-ray get scattered with decreasing their energy. According to the wave theory, when electromagnetic waves of frequency nu0 incident on an atom, it causes to electron oscillate. The electrons would absorb energy from the wave and re-radiate electromagnetic wave of a frequency v nu s, that is scattered frequency. That means the incident frequency get absorbed by electron, and therefore the scattered X-ray or wave decreases their frequency, and which is shown in there in here, that is nu0 is that is incident frequency always greater than the scattered frequency nu s. So in the Compton effect, as we know, the relation between the frequency and the wavelength, the relation is inversely proportional to each other. Therefore, scattered wave is increased wavelength, that is the lambda 0, that is incident wavelength is lower and the scattered wavelength, that is lambda s, is greater. So this is the schematic presentation of Compton effect. The incident photon falls on the electron. Electron get absorb energy and oscillate or re-radiate with an angle phi, and the incident photon gets scattered with a lower frequency and higher wavelength by making an angle theta, so that the increased wavelength of scattered photon is depending on the wavelength of incident X-ray and the angle made by the scattered X-ray. Here, here from this Compton effect, the wavelength of the scattered radiation does not depend on the intensity of incident radiation, but it depends on the angle of scattering and the wavelength of the incident beam. The wavelength of the radiation scattered at an angle theta is given by the lambda s minus lambda 0, that is wavelength of scattered X-ray minus wavelength of incident X-ray is equal to h by m0c 1 minus cos theta, where theta is the angle at which radiation scattered. m0 is the rest mass of an electron. h by m0c, that is Compton wavelength of the electron, and lambda s and lambda 0 radiation spectrum of peaks. So this is the Compton effect. So and it is also explained with the help of video animation. So watch this animation and carefully studied that topic. So thank you.
Compton scattering is one of the most important events that happened in the beginning of the 20th century that indicated that photons were real. Compton scattering was discovered by Arthur Holly Compton, and it is the inelastic scattering of a photon by a charged particle, usually an electron, that is assumed to be at rest. So, here's the idea. When light has a very large wavelength, it behaves like a wave. However, if light has a very small wavelength, it behaves like a particle, in which we call photon.
Light comes in and hits the electron and then goes down in different angle, and that's what happens when light is incident on the electron. As long as it gets enough small wavelength, it really behaves as a particle.
Compton scattering is an experiment to prove that photon is born as a particle, propagates as a particle, and dies as a particle.